Functions are like reusable blocks of code in Python. They are essential building blocks that allow you to break down complex problems into smaller, manageable pieces. By using functions, you can write code that is not only more organized, but also easier to understand and maintain. Imagine them as mini programs within your main program. Each function can perform a specific task, and you can call these functions whenever you need them. This modular approach helps in isolating different parts of your code, making it easier to debug and test. They help you organize your code and make it more efficient. By grouping related tasks into functions, you can avoid redundancy and ensure that your code is more streamlined. This not only saves time, but also reduces the likelihood of errors. Think of a function as a recipe. Just like a recipe provides a set of instructions to create a dish, a function provides a set of instructions to perform a specific task in your code. It has a name, a list of ingredients, inputs, and steps to follow. The name of the function should be descriptive enough to indicate what the function does. The ingredients, or parameters, are the inputs that the function needs to perform its task. When you follow the recipe, you get a delicious dish, output. Similarly, when you call a function with the appropriate inputs, you get the desired output. In programming, functions work similarly. They encapsulate a specific piece of logic, allowing you to reuse it whenever needed without having to rewrite the same code. You give them some input, they process it according to the defined steps, and they give you back the result. This process is known as function execution, and it is fundamental to writing efficient and effective code. This makes your code cleaner, easier to read, and less repetitive. Clean code is not only more pleasant to work with, but also more reliable and easier to maintain in the long run. You can use the same function multiple times with different inputs, just like you can use the same recipe with different ingredients. This reusability is one of the key advantages of using functions, as it allows you to write more modular and flexible code. Additionally, functions can be stored in libraries, which are collections of pre-written functions that you can use in your programs. This means you don't have to reinvent the wheel every time you need a common functionality. Proper documentation of functions is also crucial. By documenting what each function does, what inputs it requires, and what outputs it produces, you make it easier for others and yourself to understand and use your code. Testing functions individually, a practice known as unit testing, ensures that each part of your code works correctly. This makes it easier to identify and fix bugs, leading to more robust and reliable software. Functions also facilitate collaboration. When working in a team, different members can work on different functions simultaneously, speeding up the development process and ensuring that the code base remains organized. In summary, functions are indispensable tools in programming. They help you write cleaner, more efficient, and more maintainable code. By understanding and utilizing functions effectively, you can significantly improve your coding skills and create better software. Functions are essential for writing clean, organized, and reusable code. They offer several benefits that can significantly improve your coding experience and the quality of your software. Reusability. Write once, use many times. No need to rewrite the same code repeatedly. This not only saves time, but also reduces the chances of introducing errors. Modularity. Break down complex tasks into smaller, manageable chunks. This makes it easier to debug and maintain your code, as each function can be tested independently. Organization. Improve code readability and make it easier to understand. Well-organized code is crucial for collaboration, as it allows other developers to quickly grasp the structure and purpose of your code. Abstraction. Hide complex logic behind a simple function call. This means you can focus on higher-level logic without getting bogged down by the details of implementation. Imagine writing a program without functions. It would be a nightmare to manage and understand. It would be like writing a novel without chapters or paragraphs, a long, overwhelming block of text. This would make it incredibly difficult to find specific sections or understand the flow of the story. Functions act as those chapters and paragraphs, making your code easier to digest and work with. They provide a clear structure, allowing you to navigate through your code base with ease. In a team environment, functions are indispensable. They allow multiple developers to work on different parts of the code simultaneously without stepping on each other's toes. Refactoring becomes simpler with functions. You can easily update the logic in one place, and the changes will propagate throughout your codebase wherever the function is used. Testing is also more straightforward. Functions can be individually tested for correctness, ensuring that each part of your program works as intended before integrating them into the larger system. Ultimately, using functions leads to cleaner, more efficient, and more maintainable code. They are a fundamental tool in any developer's toolkit, essential for building robust and scalable software. Defining a function in Python is easy. You use the keyword, followed by the function name, parentheses and a colon. Def greet tells Python you're defining a function. Is the name of the function. Choose a descriptive name. Are parentheses that can hold parameters. More on that later. Indicates the start of the function's code block. The indented lines are the body of the function. This is where you write the code that the function will execute. Once you define a function, it's time to use it. This is called calling the function. To call a function, simply write its name followed by parentheses. Greet. This will execute the code inside the function, which in this case is printing "hello there" to the console. Think of it like this. Defining a function is like writing down a recipe, and calling it is like actually baking the cake. Section 5. Example 1. Greeting your user. Let's create a function that takes a user's name as input and greets them personally. Def greet user name. Greets the user with the given name. Print, hello, name, greet user, Alice here, is a parameter. It's a placeholder for the value you'll pass to the function when calling it. When you call, the function takes the value Alice and uses it to greet the user. Section 6. Example 2. Adding two numbers. Let's create a function to add two numbers. Def add numbers AB adds two numbers and prints the result. Sum equals sign A plus B print of the sum is sum add underscore numbers 3, 5. This function takes two parameters and adds them together and then prints the result. Section 7. Parameters. Giving instructions to your functions. In this section, we will delve into the importance of parameters and how they can make your functions more dynamic and flexible. Parameters act as placeholders for the values you want to pass to a function. They are essential in making your code reusable and efficient. By defining parameters, you can avoid writing multiple functions for similar tasks. They make your functions more versatile, allowing you to use the same function with different inputs and get different results. For instance, a single function can handle various data types or perform different operations based on the parameters provided. Think of parameters as ingredients in a recipe. Just as you can modify a recipe to create different dishes, you can adjust parameters to change the behavior of your function. You can use the same recipe to make a chocolate cake or a vanilla cake by simply changing the type of extract you add. This analogy helps to understand how parameters work in programming. Similarly, you can use the same function to perform calculations with different numbers by passing different values as parameters. This not only saves time, but also makes your code cleaner and easier to maintain. Imagine having a function that calculates the area of different shapes. By passing different dimensions as parameters, you can use the same function to find the area of a square, rectangle, or even a circle. Parameters also allow for greater flexibility in your code. You can set default values for parameters, making your functions even more robust. If no value is provided, the function can still execute using the default value. This feature is particularly useful in scenarios where certain parameters are optional. In summary, parameters are a powerful tool in programming. They enable you to write more adaptable and efficient functions, reduce redundancy, and enhance the overall readability of your code. By mastering the use of parameters, you can take your coding skills to the next level and create more sophisticated programs. Section 8. Return values, getting results from your functions. Sometimes you want your functions to not just perform an action but also give you back a result. This is where return values come in. The keyword sends a value back from the function to the place where it was called. Python def add numbers, AAB. Sum equals sign A plus B. Now, the function returns the sum. You can store this returned value in a variable in this case, and use it later in your program. Section 9. The power of parameters and return values. Parameters and return values give you immense flexibility and control over your functions. You can create functions that perform specific tasks based on the input they receive and return the results for further processing. This modularity makes your code more organized, easier to debug, and less prone to errors. Section 10. Example 3. Calculating the area of a rectangle. Let's combine parameters and return values to create a function that calculates the area of a rectangle. Python def calculate area length width. Area equals sign length asterisk width return area rectangle. Underscore area equals sign calculate area 510. Print. The area of the rectangle is rectangle underscore area. This function takes the length and width as parameters, calculates the area, and then returns the result. You can then use this returned value to print the area or perform further calculations. Section 11. Functions. Building blocks of better programs. Functions are fundamental building blocks for creating well-structured, efficient, and reusable code. They promote code organization, readability, and maintainability. By mastering functions, you'll be well on your way to writing more sophisticated and powerful Python programs. Remember, practice makes perfect. Experiment with creating your own functions, using parameters, and returning values. The more you practice, the more confident you'll become in harnessing the power of functions in your Python journey.